Hello everyone, welcome to Aptitude Made Simple. Today we are going to learn topic pipes and cistern. So this is the roadmap for learning pipes and cistern. We will look at the real-time example of pipes and cistern where we use in our day-to-day life. Then we will look at the prerequisite that we should be aware before solving pipes and cistern problems. Then we will look at the type 1 problems, followed by type 2 problems, type 3 problems, and there will be miscellaneous problems, which will be combination of this more than two type of this, 1, 2, 3, anything. So let's look at the real-time example of pipes and cistern. So most of us have water tank at our terrace. So it might be on the second floor, third floor, based on whatever building you have. So usually we have a water tank on terrace. So this is called as a tank or cistern. We store water in this, and then we utilize the same water in our kitchen and washroom via different taps or pipes, we can say. So let's assume that you have one corporation tap or pipe over here, and you get water over here, and you don't have any electric motor facility. So what you need to do to fill this terrace tank, you need to take water from this bucket and you have to go upstairs and put the water in this terrace tank, whatever tank we have. So every day when you get corporation water from corporation, maybe in the morning couple of hours, you take this bucket, you go upstairs and then put the water inside this tank. This bucket is having one issue. There is one small hole here, due to which some leakage happens over here. And let's assume that one day what it happens, usually you take so much of effort, like you take this water, you go to terrace and then put that water over there. Now let's assume one day some magic happens and you get one pipe over here by which you get the directly water inside terrace tank. So on the terrace itself, you get this water directly. So you don't need to do this activity anymore. But along with this magic pipe, one more problem happens, that here we get some leakage in this tank. So by which some water gets wasted over here. So let's recap this example. This was the bucket which was having small leakage. Then you have a water tank on the terrace, which you are using water from that in your kitchen as well as washroom. And here we have got leakage in the tank as well. Terrace water tank, you got leakage. And here you got a magic pipe by which you directly get the water inside it. Now let's try to connect this with the pipes and cistern problems. So terrace water tank, it is usually referred as a tank or cistern. Magic pipe, whatever magic pipe we got directly here on the terrace, it is called as inlet pipe because it is inserting water inside the tank. So whenever it is inserting water, we'll call it as an inlet pipe. And then water supply in bath, kitchen, whatever water you use in your kitchen, washroom, basin, all the places, that we can consider as an outlet pipe because you are getting water out of it. And inlet pipe, it will fill the tank. Outlet pipe, it will empty the tank. And bucket tank, we get leakage. Many times we have observed that we have some leakage in one of the pipe, or we get leakage in the tank also, due to which whatever it should have been filled in 1 hour, it might need more time, because the time you keep filling the water, some time also some water also get wasted during that time. Now let's move to prerequisite for solving this problem. So you should know LCM, that is lowest common multiple, and you should be able to find LCM orally. So then only you will be able to solve this question easily. I'll put the description of HCF LCM video in the description so that you can refer that directly. Now let's look at type-wise different examples. So let's say type 1. So type 1, what they will give you? Pipe A fill tanks in X hours. Pipe B fills tanks in Y hours. If together A and B are open, in how much time the tank will be filled completely? So let's look at the example. Pipe A fills tank in 10 hours and pipe B fills tank in 15 hours. In how much time tank will be filled completely if both pipes are open together? So our first step is to find the LCM of 10 and 15. So what is the bigger number in 10 and 15? It's 15. So 15 ones are 15. Is it divisible by 10? No. 15 twos are 30. It is divisible by 10? Yes. So our LCM is 30 and we can say that our tank capacity is 30 liters. So we will just make here a table like this, pipe. Then we have a tank capacity, number of hours to fill, and then 1 hour speed you can say. So we have pipe A, we have pipe B. So whether pipe A is there or pipe B is there or both of them are there, your tank capacity will be 30 only, because whatever LCM we got, that will be always capacity. You can say 30 liters. Then number of hours to fill. So for pipe A, it needs 10 hours. So you can write here 10. So if in 10 hours, it is completely filling this 30 liter, in 1 hour, how much it will fill? We'll do like 30 by 10 is equal to 3 liters. So you can say that pipe A fills 3 liters water in 1 hour. Like that, we will try to do it for B also. B is filling the tank in 15 hours. So 30 liter in 15 hours. So what is the speed of 1 hour? 30 divided by 15. Sometimes they might give you speed in the time in minutes. So you might need to write 1 minute speed. Right now they have given in hours. So we are writing 1 hour speed. So 30 divided by 15, that will become 2. Now they are looking for both pipes open. So let's assume that A plus B both are open. So whether the one pipe is open, two pipe open, any number of pipe is open. So tank capacity will always remain constant, that is 30. And what we have to find, how much time it will take to completely fill the tank. So what is the 1 hour speed of A plus B? 1 hour speed of A is 3. 1 hour speed of B is 2. So 3 plus 2 become 5. So you can see here, if in 1 hour A plus B is filling 5 liter, for 30 liter, it will require 30 divided by 6. 5 6 are 30. So in 6 hours, our tank will be filled completely. Let's look at the similar example. Pipe A fills tank in 10 hours. Pipe B fills tank in 30 hours and pipe C in 60 hours. So earlier we were having only 2 pipes. Now we have 3 different pipes, A, B, C. So our first step, LCM of 10, 30, 60. So our first step, irrespective of anything, the way we have seen in work and time also, our first step is to do LCM. So 10, 30, 60. So what is the biggest number? 60. 61 are 60. So is it divisible by 10 and 30 both? Yes. So we can say that our tank capacity is 60 liter. So let's look at here pipe. Then we have tank capacity, same table what we did. Number of hours to fill tank, and then we have 1 hour speed. So let's write down for A, B, and C. We know that tank capacity remain to be constant, whether it's A, B, C, any number of pipes. So 60 liter, here also 60 liter. Now number of hours to fill. So when we have A, how much time is needed to fill the tank? It's 10 hours. So what is the 1 hour speed? You can do 60 divided by 10. That is 6. 10 6 are 60. When pipe B is open, how much time it is taking? 30 hours. So 32 is 60. So 1 hour speed for B is 2. How much time C is taking to fill the tank? 60 hours. So 60 divided by 60, it will become 1. So what we have done, we have found out the speed, 1 hour speed of A, B, C, that is 6 to 1. Now what they're asking, how much time required to fill tank completely if A, B, C are open together. So if you see A, B, C, so we know that tank capacity is going to be constant. We have to find this. What is 1 hour speed when we consider A, B, C? It will be 6 plus 2 plus 1. 6 plus 2, 8, 8 plus 1, 9. So in 1 hour, if it is filling 9 liters, for 60 liters, how much time it will take? It's a 60 divided by 9. So you can show it as a mixed fraction. 9 6 are 54, 9 6 are 54. So you can show it as a 6 and remainder will be 6. 6 by 9. So this is the time required to completely fill the tank if we are using all 3 pipes. 9 6 are 54, 54 plus 6, 60. 60 by 9. So our answer you can simply write down as a 60 by 9 also. 60 by 9 hours. Now let's look at the type 2 problems. So what is the difference in type 1 and type 2? In type 1, they have given A and B. Both were filling the tanks and they were asking if we open together, how much time it is going to take. Now here we have inlet pipe, we have outlet pipe also. The way we are using in kitchen and washroom, those are outlet pipe, you can say. So pipe A fill tanks in X hour, pipe B empties tank in Y hours. So if together are open, how much time it will take to fill it completely. So difference between type 1 and type 2 is that earlier pipe B was also inlet pipe. Here in type 2, pipe B is outlet pipe. The question is same. If together are open, what is the time that will require to fill the tank completely? So let's look at the problem. A cistern can be filled by a tap. They might call it as a tap. They might call it as a pipe. You can write the standard table. You can use pipe or tap, whatever you are comfortable. A cistern can be filled by tap in 4 hours, while it can be emptied by another tap in 6 hours. So our first step is finding LCM of 4, 9. So for any problem, pipes and cistern of work and time, our first step will be common, that to find the LCM. So that's why we should be very comfortable with LCM. Yeah, so LCM of 4, 9. So what is the bigger number? 9. 9 ones are 9. Is it divisible by 4? No. 9 twos are 18? No. 9 threes are 27? No. 9 fours are 36? Yes. So we can say that 36 liter is our total capacity of water tank. Now let's look at pipe. Then we will look at tank capacity. Then we will see number of hours required to fill or empty. Here we have one tank, which one pipe which is filling it, and one which is emptying it. So, and 1 hour speed. So let's look at A. Tank capacity will be 36 only. So let's take A and B. Both the places, our capacity is same, 36, 36. Now number of hours required to fill. So for A, it can be done in 4 hours. So our 1 hour speed will be 36 by 4. That will be 9. This is the inlet pipe. Now this is the outlet pipe B, which can emptied by another tap in 6 hours. So whatever they have given can be emptied by another tap in 9 hours. Sorry. Yeah. So 36 is the capacity. And in 9 hours, it is making it empty. If it is already completely filled, 36 liters, and if we start the tap B, it is going to empty it in a 9 hours. So what is the 1 hour speed? 36 by 9, that will be 4. But what is the difference between pipe A and pipe B? Pipe A is doing some positive work because it is filling the tank, and pipe B is doing some negative work because it is emptying the tank. So if we write the outlet pipe, we should write the negative symbol over there. For pipe A, you can keep it as a 9. Wherever it is a leakage or it is taking water out of it, so we can say that it is doing negative work. So it is emptying the tank. So we will put that as a minus sign. Now, if both pipes are open, A plus B, our capacity is going to be same, 36 only. Now, how much time it will be required to fill the tank completely? So when we look at A plus B, now we need to add 9 plus minus 4 because our second tap, that is a pipe B, is outlet pipe. So 9 plus minus 4, that will become 9 minus 4, that is 5. So we can say that in 1 hour, it is our speed is A plus B is 9 plus minus 4, that is 5. So to fill 36 liter, 36 upon 5, which you can say it as a 7.2 hours. So our answer for when A plus B both are open, our speed is 5. So 36 by 5, 5 sevens are 35, 5 twos are 10. 7.2 hours, it will be filled completely. Let's look at the type 3 problem. Let's understand what is the difference in type 1, type 2, type 3. So type 1, both inlet, and they were asking both are open, then how much time it will take. In type 2, one was inlet, one was outlet, and if both are open, how much time it is going to take. Now, here is the situation in type 3. Usually, pipe A is going to fill tank in X hour. But due to leakage, it can be leakage in a pipe, it can be leakage in a tank. The way we have seen in bucket also, we can get leakage like that. So normally, if it is filling the tank completely in X hours, due to leakage, it has taken some more time. So you know that if it is having leakage, it is definitely going to get more time because some of the water keep wasting whenever we are filling water in the tank. So pipe A fills in X hours, and due to leakage, it takes some more time. So they will ask you that if just due to leakage, if we have to empty the tank, how much time it will require. So if tank is completely filled, and let's assume that we are not making any inlet pipe on, but we have leakage in that tank. So let's assume you completely fill your tank before you go to outstation. And if there is a leakage over the period of time, if you come after 2-3 weeks, definitely half of the water or most of the water would have come out of it because there is a leakage in the tank. So let's look at the problem. An electric pump can fill tank in 3 hours. Because of leak in the tank, it took 3 1/2 hours to fill the tank. So now what is the common difference between the other problem and this? All the places we have a proper natural number as a whatever 10 hours, 20 hours, 60 hours. But here they are given us 3 and 3 1/2. So when you do 3 1/2, it is nothing but like this mixed fraction 3 1/2. So when you convert this mixed fraction into normal fraction, 2 into 3 is 6 plus 1 7. That is 7/2. So now our goal is to find the LCM of 3 and 7/2. Usually we start writing the table of number and then we get the LCM of any pair. But here we cannot write the table of 7/2. But what we are looking for, something which is coming in the table of both the numbers. So if we multiply both the number, can we say that whatever answer we are going to get, it will be in the table? You take any two numbers, like say 4 and 5. 4 5s are 20. 20 4 and 5, both the tables 20 will be coming if we multiply them. But we cannot take this fraction as our LCM because it will be difficult for us to calculate the tank capacity if we keep like this. So we just try to multiply it by 2 so that our denominator will get cancelled and we will get the answer as 21. So we can say 21 is the number which is completely divisible by 3 as well as 7/2. So our tank capacity is 21 liter. Let's write down the table. Pipe. Here we have a pump, we can say, but standardized, we are just writing pipe over there. Tank capacity. Tank capacity is going to remain constant. Number of R to fill / empty. Here we have leakage also, so we need to write down empty as well as fill, both the things. And then we have 1 hour speed. So 1 hour speed. So we have only one pump here and we have leakage over here. We can say this as a plus leakage, because they have given us the time considering both the things are open. Okay. So A, when we just have electric pump, how much time it is taking? 3 hours. So 21, 3 hours. So what is the 1 hour speed? 3 sevens are 21. So we can say that if there is no leakage, normally it will do with 1 hour as 7 liter. So 777 in 3 liters, that pump will completely fill it. Now, due to leakage, what it happened? It took 7 by 2 time. So down 7 by 2 time. So it took 7 by 2. So how much is the 1 hour speed? So 21 divided by 7 by 2. So when you do fraction divide by fraction, what you need to do? You multiply it and get the reciprocal of denominator. 7. So earlier it was 7 by 2 in the denominator. Now it will be into 2 by 7. So if you 7 3s are 21, if you simplify this, and 3 into 2 become 6. So we can say that when pipe and leakage, both the things were there, our speed was 6. Now you can see here, when only pipe was there, our speed was 7. When there is a and leakage, then our speed is 6. So what can be the leakage speed we can say? Can we say 7 minus 6, which is 1? So our leakage speed is 1. You can write it as a -1 for reference also. But leakage speed is 1 hour, 1 liter per hour, you can say. So now if you have to, what they are looking for, if the tank is full, how much time it will take the empty it? So when tank is full, it will be 21 liter filled. Now see, if we have 1 liter per hour is the speed, in how many hours this 21 will be over? 1 into 21. In 21 hours, it will be empty. 21 hours, tank will be empty. Earlier, they have given us A speed is 7, A plus leakage speed is 6. Leakage is going to do some negative work. So 7 minus 6 is 1. So we can say that in each hour, 1 liter water is going. So 21 upon 1, you will get answer as 21 hours will be empty. Now let's look at the miscellaneous problem. So in miscellaneous problem, what will happen? It might be combination of any two of them or more than two of them. Type 1, type 2, type 3. Any of the combination you will get. So two pipes A and B can fill in 15 hours and 20 hours respectively, while third pipe C can empty full tank in 25 hours. So first of all, let's look at the 15, 20, 25. So first of all, we need to find the LCM of 15, 20, 25. So what is the bigger number? 25. So you start looking at the table of 25, 25, 50, 75, 100. Is it divisible by 15 and 20? So you'll keep doing like this and you will get it as a 300 as LCM. If you feel that with this method for this problem, you are not able to get LCM, you can use prime factorization method and you can get the LCM of it. So 300 liter is the tank capacity. So let's just write down first part, whatever they have written. We are not looking at the other part at the moment. What they have given, A and B can fill in 15 and 20, while C can empty in 25 hours. So pipe, then tank capacity. This is common. Number of hours to fill or empty, because C is emptying the pipe. So C is the outlet pipe. And here 1 hour speed. So pipe A, pipe B, pipe C. Irrespective of any tank, irrespective of any pipe, the capacity will be 300 only. 300, 300, 300. What is the time required by A to fill the fill the tank completely? 15 hours. So what is 1 hour speed? 300 divided by 15. To do 300 divided by 15, we'll get 15 to the 30, 15 0 0. So 20 is 20 liter per hour is the A speed. Let's look at B. It takes 20 hours to fill the 300 liter tank. So 300 divided by 20, 1010 will get cancelled and you'll get 15. So 15 liter per hour is the speed of B. And for C, it takes 25 hours. So 300 divided by 25. If you do 25 ones are 25, 25 twos are 50. Our speed is 12, but here we need to make sure that as C is emptying the tank, that means we need to put it as a minus sign because it is doing negative work. Filling the tank is the positive work. Emptying the tank is the negative work you can consider. So we need to write C as a minus 12. Now what they're looking further, all three pipes are opened in the beginning. So A plus B plus C, all three are open. 300 we need to fill, irrespective of all three or one pipe, we need to fill 300. When three pipes are open, we can say 20 plus 15 minus 12. So 20 plus 15 is 35. 35 minus 12 is 23. So we can understand that A plus B plus C, when three are open, you will get the speed of 1 hour is 20 plus 15, 35 minus 12, 23. Now, after 10 hours, C is closed. So for 10 hours, if all these three pipes are open, A plus B plus C, can we say that 23 into 10, because 1 hour speed is 23. So 23 into 12 will become 230. So 230 liter water will be already filled in the tank. Now, in how much time will tank will be full? C is closed. In how much time tank will be full? Now, if C is empty, no, if C is stopped, only A plus B is remaining. What is the A plus B speed? You can say 20 plus 15 is equal to 35. So 1 hour speed for A plus B is 35. And what is the remaining water? Like how much water we still have to fill? 300 minus 230 because original capacity was 300. 230 is already filled. So now 70 liters is remaining. And our speed is 1 hour 35 liter. So how much time it will take to fill completely? 70 divided by 35. That will become 2. So in 2 hours, our tank will be filled completely. Thank you.